A year lasts 10 hours. One side never sees darkness. The surface is hot enough to melt rock. And according to everything we know about planetary physics, this world shouldn't be able to hold on to air. But it does, and nobody can fully explain why. The James Webb Space Telescope recently turned its infrared gaze toward one of the strangest rocky planets ever discovered. What it found there has forced scientists to rethink some basic assumptions about how planets work. Because this world isn't behaving the way our models say it should. Let's set the scene. The planet is called TOI 561b. It orbits an ancient star roughly 10 billion years old, nearly twice the age of our sun. This makes it one of the oldest rocky planets we've ever studied. And it's close to its star, absurdly close. So close that it completes an entire orbit in just over 10 hours. While you sleep tonight, this planet will experience an entire year. At that distance, you might expect a scorched, airless wasteland. The stellar radiation should be overwhelming. Any atmosphere would be blasted away within millions of years, stripped molecule by molecule into the void. That's what the models predicted. That's what scientists expected to find. Instead, Webb detected something that made researchers stop and recheck their data. The planet was cooler than it should be. Not by a little, by a lot. A bare rock that close to its star should be glowing at temperatures well over 2,000 degrees. But the readings suggested something was distributing that heat, spreading it around, moderating the extremes, something like an atmosphere. Further observations confirmed it. 2I561b appears to have a thick envelope of gases surrounding it, an atmosphere that by all rights shouldn't exist. So what's going on? Here's where it gets strange. Scientists now believe this planet might be what they call a wet lava world. Picture a planet where the entire day side is covered in a churning ocean of molten rock, not water, magma. Liquid stone heated to thousands of degrees, constantly roiling and cycling. And that magma ocean might be the key to everything. When rock melts, it releases gases. Volatile compounds that were trapped inside get liberated into the atmosphere. On Earth, volcanic eruptions do this all the time, releasing carbon dioxide, sulfur, water vapor. But on TOI 561b, the scale is incomprehensible. The entire day side is one continuous volcanic event. An ocean of lava constantly outgassing, pumping fresh atmosphere into the sky faster than the star can strip it away. Think about that for a moment. The planet is regenerating its own atmosphere in real time. But that's only half the story. Remember, this planet is tidally locked. One side always faces the star. The other side is locked in permanent darkness. The day side boils. The night side freezes. And at the boundary between them, something fascinating happens. The atmosphere flows from the hot side to the cold side, cools down, and cycles back. A global circulation pattern driven by the most extreme temperature gradient imaginable. This circulation might be what keeps the atmosphere stable. The constant movement prevents any single region from losing all its gas. The magma keeps replenishing what escapes. The system reaches a kind of violent equilibrium, hostile to life as we know it, but stable enough to persist for billions of years. And here's the part that keeps planetary scientists awake at night. If this works on TOI 561b, it might work on countless other planets we've written off as uninhabitable. For decades, we assumed that any planet too close to its star would be a dead, airless rock. We filtered them out of the search for habitable worlds. We focused on planets at comfortable distances in the so-called Goldilocks zone. But what if we were wrong? What if there's an entire category of planets, lava worlds with recycling atmospheres that we've been ignoring this whole time? The universe might be far stranger and far more capable of supporting complex chemistry than we ever imagined. Now, to be clear, nobody is suggesting TOI 561b harbors life. The conditions are far too extreme for anything resembling biology. But the chemistry happening there is extraordinary. Complex molecules forming and breaking apart in that superheated atmosphere. Reactions driven by stellar radiation and volcanic heat. It's a planetary scale laboratory, and we're just beginning to read the results. What does this mean for us? First, it means our models need updating. The discovery of an atmosphere where none should exist isn't a failure of observation, it's a failure of prediction. Our understanding of atmospheric escape, of how gases interact with intense radiation, of how magma behaves under alien conditions, all of it needs revision. This is how science works. The universe gives us data that doesn't fit, and we have to adjust. Second, it changes the search for other worlds. When the next generation of telescopes comes online, scientists will need to look more carefully at planets we previously dismissed. The most extreme environments might turn out to be the most interesting. And third, it reminds us of something humbling. We've been studying planets for centuries. We've landed probes on Venus and Mars, We've mapped the moons of Jupiter and Saturn, we've cataloged thousands of exoplanets around distant stars. And still, we're finding worlds that break our assumptions, that do things we didn't think possible. The universe is not obligated to make sense to us. It simply exists in all its bizarre and beautiful complexity. Our job is to watch, to measure, to wonder, and to update our understanding when the data demands it. 2I561b is a planet that shouldn't exist the way it does. An ancient world wrapped in an impossible atmosphere, sustained by an ocean of liquid rock, orbiting its star 13 times faster than Mercury. Every part of it challenges something we thought we knew. And that's exactly why it matters. Because the moments when our models break are the moments when we learn something new. The impossible observations are the ones that push science forward. Today it's a lava world with an atmosphere it shouldn't have. Tomorrow it might be something even stranger. The Webb telescope will keep watching. More data will arrive, and slowly, piece by piece, we'll build a better picture of what planets can be and what they can do. For now, we sit with the mystery, a world that defies explanation, glowing in the dark, waiting to be understood. What do you think is happening on TOI 561b? Is the magma ocean theory enough to explain this, or is something else going on? I want to hear your take.